Good day, sir. Good day, everyone. How are you all? How are you? My name is Jafaru Abdullahi Sado. I'll be taking you mathematics, and today we'll be looking at polynomial. Again, be looking at algebra and precisely be looking at polynomial, and then at the end of the lesson, we should be able to understand the concept of polynomial. We should be able to understand and apply the remainder theorem and factor theorem to polynomial, all right? And then we should be able to factorize third degree polynomial. By the end of this lesson, you should be able to have a grasp of those, all right? Right? So we start off to first of all see what is polynomial actually is all about. What polynomial actually is all about, right? Right, so polynomial is an algebraic expression of the form of this. So the general equation for polynomial, all polynomial has take this form, where we have a, 0, x power n, a1, a2, right? X power -1, so whereby the power of the n decreases with whole numbers. So basically, we're saying all polynomial takes this form, right? Where a are the coefficient of x, right? The a's, they are the coefficients of x. So your AO can be different from your A1 different from your A2, and the likes. And then the power of the x, so the first one being n, and then the next one, the consecutive one being n-1, n-2, n-3, and it goes down like that, right? So we're saying all polynomials have these formats, right? Okay, and then we talked about n. We said n is referred to as the power, as the degree of the polynomial, where n is a whole number, n must be a whole number, and it's called the degree of the polynomial. So the value of n has to be whole number, so it shouldn't be a fraction. Okay, so for it to be a polynomial, the value of n should be, n must be an integer. All right, understand that can be an integer, must be a whole number. All right, so when you take back polynomial, we have different forms of polynomial. We can have 3x minus 8, we can have 8x squared plus 3x minus 5, we have 3x squared minus 7x minus 6, and the likes. All right, so these are examples of polynomial. So in this first one, the first one here, for example, the 3x plus the 2x plus 3 is a polynomial, all right? And then we say the degree of the polynomial is 1. What do you mean by that? That means the highest power of the polynomial is 1. So the word degree of the polynomial refers to the highest power of the polynomial. So in this case, we're saying the degree of this polynomial is 1. All right. Okay. And then we refer to this one as being binomial, being two terms. Is that okay? Here it has got two terms. We call it binomial, a form of polynomial. Okay. And the degree of the and it has a degree of 1. So we can have other type of polynomial, can have like this, also called the linear one. Linear means the highest power is 1. It's called a binomial. It's a linear polynomial. They can have quadratic ones. So quadratic expressions are also a form of polynomial. All right. And they call it a trinomial. All right. Why? Because there are 3 terms, and then the degree of this polynomial, we said is what? The highest power 2. So it's of degree 2. All right. And precisely you have the cubic polynomial, which we can take this kind of form. X power 3 minus 7x minus 6. So if you ask now what is the degree of this polynomial, is what? 3. 3 being the highest power. Okay. So expressions such as x power half plus 3x, this kind of expression, we do come across them in our algebra questions. So you have such kind of expression, so it's saying they are not polynomial. So why are they not polynomial? Because the power is not a whole number. The value of n is not a whole number. So we're saying these kind of expressions are not a polynomial. All right. Okay. Now, so next, let's see now, how do we factorize cubic polynomial? So looking at factorizing cubic polynomial. So in this case, we'll start off by learning factorization of sum and difference of two cubes. So we have sum and difference of two cubes. How do you factorize that? For example, say you have x power 3 s cubed plus a cubed. So how do you simplify this? So this is sum of cube. So when you have expression with like this, how do you factorize it? So what do? We're saying this expression is written like this. This is what it equals to. And how do we came about that? Here we're going to, first of all, find the square root, the cube root rather, the cube root of the first term. We find the cube root of x cubed, which is going to be what? X. First, open your two brackets. You have the small one and the bigger one, okay? So again, to factorize sum or difference of two cubes. Again, for example, f cubed plus a cubed. So open a small bracket and open another big bracket. All right. So now, so what do we do? So we first have to get the cube root of the first term. So the cube root of f cubed to be what? X. So put your x here, and then get the cube root of a cubed, the second term. The cube root of a cubed is what? A. So you put it next to your x, right? That for the first bracket. And then to get the content of the second bracket, what do? You square this first term. You square x to give you x squared. And then you squared your a to give you a squared, okay? And then how do we get this middle term? How do we get this middle one? So the middle term you get by multiplying the two terms, the x multiplied by a. So x multiplied by a, which will give you what? xa. Then multiply it by -1, or basically change the sign. Okay, if it was negative, it becomes positive, or positive becomes negative. So to get the middle term, we multiply these two terms, x times a, which is xa. So multiply by -1, and that will be negative xa. So negative x will be the middle term. So let me go back that again. To factorize this cube, don't forget the cube root of this. The cube root of s cubed is x. Put it by x. The cube root of a cubed is a, right? So we are done with the first bracket. So to get the other big bracket, you square this first term to get the first term here. You square this last term to get the last term here. You square your x to get your x squared, square your a to get your a squared. And then to get the middle term, multiply the two terms, x times a, that gives you xa. Then by multiply by -1, we give you negative xa, right? So the same thing applies to this. The difference now, the difference of cube, s cubed, the cube root of s cubed is x. Cube root of a cubed, a, right? So for the bigger bracket, you square the first term, x squared is x. Whatever is there, you square it. You get this here. And then to get this other last term in the bracket, you say what? A squared, we give you what? I mean, square this, your term, negative a squared. You square the negative a here. Okay. When you square the negative a, then get what? Positive a squared. And then to now get the middle term here, this middle term, you multiply x times minus a. And that will give you minus ax. So minus ax times -1 will give you positive ax. Okay, you always multiply by -1 to give you this middle term. Okay, and that's how we do cubes. So just as a side note, don't forget your difference of two squares. Maybe have, for example, a squared minus a squared. So this we know that's going to give us x minus a bracket x plus a. So let's take note of that. Okay, hope you understand that. Right. So the next one, let's say an example now. Let's see how that works. Factorize this. Factorize this expression. Okay, how do you factorize this expression? So we're saying, what do we do? To factorize 8s cubed minus 27x minus 27. You open small bracket and you open a big bracket, okay? So for the small bracket, you find the cube root of this first term. You find the cube root of this. So the cube root of this, cube root of 8s cubed will give you what? 2x. Okay, because the cube root of 8 is, the cube root of 8 is 2, the cube root of s cubed is x. So, and then you find it, then you have your, you keep your sign, negative, you keep the negative sign, right? Then you find the cube root of the other term, the 27, which is what? 3, to get there, all right, fine. And then to get the other big bracket, now you have to square this first term. You square the first term to give you the first term here. And then you square this other term, the second term in the small bracket, this, to give you this last term here. Understand? So negative 3 squared will give you what? Positive what? 9. And then to get this middle term here, to get the middle term, you multiply 2x times 3. 2x times minus 3, that gives you minus 6x. Then times minus 1 give you positive 6x. So x squared gives you 4x squared. So minus 3 times minus 3 squared give you positive 9. Then to get this middle one, you say minus 3 times 2 give you minus 6. Minus 6 times 1. Don't forget to always multiply by 1. Or we just quickly change the sign and give plus 1. So then you have factorized your cubes. Okay. That's example 1. So let's see another one. For example, let's factorize s cubed minus 63. X cubed plus 64. So x cubed plus 64. So what do? You open two brackets, the small and the big one. So you find the cube root of s cubed, which is x. The cube root of 64, which is 4. Okay. And then you square this term, you square x to give you s squared. Then you squared positive 4 to give you positive 16. And then to get the minus, the middle term, you multiply x times 4. That is 4x. Multiply minus 1, give you minus 4x. And that is done. So that's how to factorize sum or difference of cubes. Right. Now, next, let's see factorizing by grouping in pairs. Factorizing by grouping in pairs. So if you can have cubic functions like this, cubic equations like this. For example, 2x cubed plus 4x squared plus 3x plus 6. Factorize this. Right. How do you factorize this? If you look properly here, you're going to see that these two here are, I've got like terms. So if you pair them, you put them, how many terms are there? 4. Right. So it's easy to pair up. But if there were 3 terms, then you have to now, that will be a trinomial, whereby you need to make it 4 by looking for 2 factors to multiply to give you the constant term and to add to give you the coefficient of the x. So you have to make it 4 if it's a trinomial. Okay. If there were 3 terms, you have to look for a way of making it 4 by looking for factors. But now here they are 4. So when they are 4, then you can now pair them up and factorize by pairing, by grouping. Okay. So now these are 4 terms, you can group them. So this and this being grouped and this being grouped. So we're gonna have the 2x plus the 2x cubed plus 4x squared. What is common between them is 2x squared. So pull out your 2x squared. When you pull out your 2x squared, then we left it what? X plus 2. You understand? We left it x plus 2. All right. And then in the other side, for the 3x plus 6, the common term is what? The common term between the two of them is plus 3. So pull out your plus 3, and then we take care of plus 3, we left it what? X plus 2. And then from there, you see these two are, we have a common factor there, something common there, you factorize further. You further factorize, bringing out your 2x, x plus 2, and then keeping your 2x squared plus 3x in another bracket, and then it's factorized. Okay. Another example you can check again is this here. The same thing, you have to factorize it by grouping. So once you see this, you are not supposed to be told to factorize by grouping. The question is just factorize. So because there are 4 terms, so you must just group them. Or sometimes you need to regroup. Sometimes when you group them, if it's not going to give you, if it's not going to work out for you by giving you a common term, then you may need to do regrouping. All right. But in this case now, we have 3x cubed plus x squared minus 12x plus 4. So when we group these two together, when we group this, so we're going to find out that our x squared will be common. So x squared is common, so pull out your x squared, be left with what? 3x plus 1. All right. 3x plus 1. All right. And then for the other second two terms, so if you check that, what's common there is negative 4. So negative 4 into 3x plus 1. Remember, this here become what? Positive. So that negative times positive can give you a negative. So we're going to have this. And then from here now, there are two terms here, this here and this here. So between them, what is common? 3x plus 1. So we take out the 3x plus 1. So when 3x plus 1 comes out, we are left with what? S squared. S squared minus what? 4. Right. We're going to have what? S squared plus 3. I mean 3x plus 1. That is what is common. Then your S squared minus 4 be put together in another bracket. Okay. And then this one is another difference of squares. So this is another difference of squares. It can be further factorized, as we did said, that when we have difference of squares, so we're going to factorize that further by saying x minus 2 and then x plus 2, because 4 is a perfect square. So we are having here s squared minus 2 squared, which is the difference of two squares. That makes you 2 minus x minus 2, then x plus 2. Then it's fully factorized. Okay, right. So let's progress from there. Right. Let's see function notation now. Function notation or f of x notation. Okay, f of x notation. Now, for example, if f of x equals to x squared minus 2x plus 1, find the value of f of 1 and f of minus 3. Right. If f of x equals to 2x minus 1 plus 2x, I mean x squared minus 2x plus 1, find the value of x of 1. What does that mean? Here it says if f of x. So now we are looking for f of 1, meaning where x is, we take it out, we replace it with what? 1. So yes, says f, here calls it f of x, and then is what? F of 1. So where x is now is being replaced by 1. So meaning in all the equation, wherever you find x, we replace it with 1. So we have f of x, f of 1 equals to 1 squared minus 2 times 1 plus 1. And then that will give us 0. 1 squared is 1. Minus 2 times 1 will give you minus 2. Plus 1 will give you 0. Right. And then f of minus 3. F of minus 3. So meaning wherever you find s, you put what? Minus 3. Because f of s was this. So if you're going to find f of minus 3, so meaning wherever you got x, wherever you get x, now it is what? Minus 3. So you represent with what? Minus 3. So, and then whatever you are substituting, put in brackets, right? So whatever you're substituting, always put it in brackets. So we have f of minus 3 equals to minus 3 squared minus 2 times minus 3 plus 1. So when you square anything negative, it becomes positive. Negative 3 squared gives you positive 9. So negative 2, negative 3 give you positive 6, then plus 1, and that'll give you 16. All right. Right. Let's see the other one here. Let's see the other one. Example 2 now. So you say that if g of x equals to negative x squared minus 3x minus 1, find g of a minus 3. If g of x equals to negative x squared minus 3x plus minus 1, find g of a minus 3. Right. So the same thing, it implies that yes says g of x. Here is we to find g of a minus x. So the same process, we're replacing or we're substituting x for a minus 3. So in the expression, wherever we have found what? X, so now we'll be replacing it with what? A minus 3. Right. So our equation, okay, then our equation then becomes, so instead of whatever we're substituting, always put in brackets. So keep your minus, and your x is a minus 3, all squared. Then minus 3x, so that'll give us minus 3, a minus 3 minus 1. All right, and then you can now simplify that. So you keep your minus 1, just always keep this minus first, first for open up this bracket, or for foil this bracket. Okay, foil this, that will give you a squared minus 6a plus 9. I'm sure you know how we come about that. A squared minus 6a plus 9. So that gives you that. Then this minus 3, then open up this other bracket, minus 3 times a, negative 3a, negative 3 times negative 3 give you positive 9, then minus 1. All right. And then we can now, then this minus, then distribute into the bracket. Then this minus 2 distributes into the whole bracket. And that give you negative a squared, then positive 6a, then negative 9, then negative 3a plus 9, negative 1. So simplify that, collect like terms. So here gets negative a squared 6a minus 3a give you positive 3a. Negative 9, positive 9 give you 0. Then minus 1. So that gives you, so basically g of a minus x will give you that amount. So even sometimes you are given a number or you are given a funny expression like this, it's basically the same thing. You just need to manipulate your algebra, you need to manipulate it. All right. Okay, that being said, now, so let's see now, dividing polynomial using long division. Dividing polynomial using long division. So how do you divide polynomial using long division? For example, divide 3x squared, right? 3x squared, right? 3x squared plus 7x minus 6 by x plus 3, right? So divide 3x squared plus 7x minus 3 divided by x plus 3. Okay, so how do we do that using long division? So this expression we are dividing is termed the polynomial. You see now, this is your polynomial. Is that okay? And then what you are dividing by is called your divisor. Okay, so you got polynomial. We already said it's a polynomial, precisely a trinomial. All right, so we're dividing a polynomial by another term called the divisor. So whatever you're dividing by is called the divisor. So whatever answer you get is called the quotient. Whatever answer you get is called the quotient. And then if there's any remainder, then we refer to it as the remainder. So basically you're going to have polynomial. So every polynomial equals to the divisor, what you're dividing by, multiplied by the quotient. The quotient refers to the answer, the value you get, and your remainder. So basically, polynomial is divisor multiplied by quotient plus your remainder. Okay. For example, to illustrate that with an example, say we have 21 divided by 7. 21 divided by 6, for example. 21 divided by 6, or 20 divided by 6, for example. 20 divided by 6. So you're saying the 20 is a sort of your polynomial. The 6 is your divisor. So 20 divided by 6 will give you 3. So the 3 is referred to as your quotient. And then we'll be remaining with what? 2. So 20 divided by 6, we're going to get what? 3, remainder 2. So 20 is your polynomial, 6 is your divisor, 3 is your quotient, and your 2 is your remainder. So when you multiply your divisor, multiply by your quotient, plus your remainder, we give you the polynomial, or called the dividend. So the dividend also means the polynomial, which implies what we are dividing, right? So now, that is by the way, so going back this now, divide this amount. Divide 3x squared plus 7x minus 6 by x plus 3. So what do we do? So we just follow these steps here. You put your polynomial or your dividend, you put it under the root like that. Usually there are several ways of doing this. So, but using the long division, this is how we go about it. But there could be other way by which you can deal with this. All right. So now, to use the long division to do this, you put your dividend or your polynomial, whatever you are dividing, you put it under the root there. Then you put your x plus 3, you put it outside the root. Right. So what do we do? Then you start one after the other. You say 3x squared. 3x squared divided by x. 3x squared divided by x. That will give you 3x. All right. Then you say 3x times x to give you this bottom here, 3x squared. Then 3x times 3 to give you 9x. All right, so let me take that again. So your dividend or your polynomial, what you are dividing, you put it under the root. Okay, 3x squared plus 7x minus 6, right? We're dividing by x plus 3. So put your x plus 3 outside here. All right, so start one after the other. Start from this first term, 3x squared. 3x squared divided by x. That will give you 3x. Now, so getting the 3x now, 3x multiplied by these two. 3x multiplied by x, then you have 3x squared. 3x multiplied by 3, then get what? 9x. Right. So use the 3x to multiply these two. 3x multiplied by x, 3x. 3x multiplied by 3, 9x. Okay. Then on getting to this point, what do you do? Then you change the sign now. You now subtract, basically. You subtract this now. You change the sign of this, you subtract. Say this minus this, 3x squared minus 3x, that gives you what? 0. You understand? You are subtracting here. 3x squared minus 3x, you get 0. Then 7x minus 9x. 7x minus 9x give you negative 2x. All right. Then you bring down your 6. You bring down your negative 6. This negative 6 will be brought down here. Okay. Right. So don't forget 7x minus 9x is negative 2x. So you must say the top one minus the bottom one. Again, 3x squared minus 3x squared, that gives us 0. That's gone. Then 7x minus 3x will give you negative 2x. Okay. Then bring that up, negative 6. Right. So then we get to what? Minus 2x minus 6 sharp. Now, we carry on now. I'm going to say negative 2x divided by x. Negative 2x divided by x, that will give us negative 2. All right, give us negative 2. So that's where we get this negative 2. Now put it next to the 3x we had with negative 2. The negative 2 will be used to multiply both of these here. So negative 2 multiplied by x, then we have what? Negative 2x. Negative 2 multiplied by positive 3. That give you negative 6. All right. Negative 2 multiplied by x, negative 2x. Negative 2 multiplied by 3 give you negative 6. Okay. Then what do? You now have to subtract now. You have to subtract this now. So negative 2x minus negative 2x. So this minus this. So minus give you plus. So that means then we're going to have what is 0. So the minus 2x plus 2x, that gives you 0. All right. Then minus 6 minus 6. Minus 6 at the top, minus 6. You always minus the bottom one. Minus 6 minus 6. That'll give you minus 6 plus 6, and that'll be 0. So everything comes to 0 here. And then that means there's a 0 remainder. Okay, that means there's a 0 remainder. Okay, and then our answer then, that means this is our quotient. So these are divisors, these are quotient because they have a 0 remainder. Do we understand? Okay, so the dividend now, which is your polynomial, equals your divisor times quotient plus remainder. We did said that. That's like a general equation for polynomial. Dividend equals to divisor multiply quotient plus remainder. So in this case now, our dividend, our polynomial, is our polynomial, which is what? 3x squared plus 7x minus 6. So when you multiply these two together and plus it with this 0 remainder, then it should be equal. So that means this is our answer basically. So when you divide this by this, you get, if you divide 3x squared plus 7x minus 6, if you divide it by x plus, when you divide it by x plus 3, then you get what? 3x minus 2. Okay. Hope you understand that. Right. So let's see the next one. Let's see another example to illustrate that more. All right. Now, let's see now. Divide x cubed minus 16x plus 4 by x minus 2 using the long division. Okay, divide x cubed minus 16x plus 4 divided by x minus 2. Okay, using the long division. So the same thing, same process we are doing. Put your dividend under the root. So have your root there, put your dividend or your polynomial under the root. Okay, right. But if you observe properly now, if you observe nicely, you're going to see that the powers, when we started with the topic, we say the power of the n will always decrease by 1. It must always decrease by 1. So this is x power 3. So x power 2 is missing. This is x power 1. So x power 2 is missing. Okay, must pick that up. We must see that, must observe that. So because x power 2 is missing, then use 0 to represent it. So whenever anything is missing out like this in that order, it must be 3, 2, 1, 0. It must go in that order, decreasing in powers of 1. Right. So now, so in this case now, you see it goes 3, it goes 1. That means x power 2 is missing. So to fix that, you just put 0 x power 2. So you now have to rewrite it like this. Okay. So if it is the x that is missing, if it's the x term that is missing, we put what? 0x. Right. But it is x squared term that is missing. So you put 0x squared. Okay. So you have what? S cubed plus 0 s squared, s cubed plus 0 s squared, then minus 16 plus 4. We're just going to rewrite it properly like this. All right. And then we are dividing by x minus 2. Okay. So again, we start all over again. We start from this first term, s cubed. S cubed divided by x. S cubed divided by x. That gives us x squared. Leave all these ones. We're going to get there later. I'm going to leave the s 2x minus 12. Leave that. So we're starting again. S cubed divided by x. That will give you x squared. Right. So s squared times x. That use the s squared now to multiply these two terms. And you arrange them under here. So s squared times x give you s cubed. S squared times minus 2 it give you minus 2x. Okay. And then what do? We now subtract. Here we subtract. So s cubed minus s cubed, that will give you 0. Then is 0x squared minus 2x squared is 0x squared minus 2x squared. That will give you positive 2x squared because negative give you positive. So is 0x squared minus 2x squared give you positive 2x squared. Okay. Then we bring this down, right? One after the other, bring this down. Okay. Okay, you leave this out. So we bring this negative 15 down, right? Then we start again. 2x squared minus, 2x squared divided by x. 2x squared divided by x. That'll give you positive 2x. So you're going to write your positive 2x here. Okay. So again, this 2x squared divided by x give you positive 2x. Then this 2x will be used to multiply both of these terms. So 2x times x give you 2x squared here. Right. 2x times minus 2 give you minus 4. Right, give you minus 4. We get that. And then you then subtract now. So subtracting, you're saying when you get here, you always subtract. So subtract 2x squared minus 2x squared, that gives you 0. So you can get 0 there. Right. So negative 16x minus 4x. Negative 16x minus 4x. That will make it negative 16x plus 4x. And that will be negative 12x. Right. So we're going to have negative 12x here. Okay. Then what do? Lastly, you now bring the 4 down in that order. Then you bring the 4 down. Right. Then you have what? Minus 12x plus 4. Then you start again. This negative 12x divided by x. That'll give you negative 12. Again, negative 12x divided by x give you negative 12. What do you do with negative 12? You use the negative 12, you write it up here. And then what you're going to do with it? You're going to use it to multiply both of these terms, right? So negative 12 multiplied by x. Then you're going to have what? Negative 12x. Okay, negative 12x. So negative 12 multiplied by negative 2 will give you positive 24. Will give you positive 24. Then what do? You now subtract again. You subtract here. So minus 12x minus 12. Minus 12x minus 12x. And that'll give you minus 12x plus 12x. And that'll give you 0. Okay. And then 4 minus 24. They give you minus 20. So here we have this. So here there's a remainder because now we're done with all the terms. There's something remaining here. We call it the remainder. Okay. So basically, now we're saying if you divide x cubed minus 16x plus 4 divided by x minus 2, so our answer will be what? S squared plus 2x minus 12. Then there'll be remainder of minus 2. Okay. So let's go over that again quickly. This, you put your dividend or your polynomial, you put it under the square root, okay? And again, we said, whenever any term is missing, what do? You replace with 0. You keep it 0. Use 0 to keep it. Here, our x squared is missing. The x squared term is missing. We make it 0 x squared, right? We have it in the order x power 3, x power 2, x power 1, then x power 0, right? Then again, x power 3 divided by x. We give you x squared, right? So when you get here, you write your x squared up here. So now use the x squared to times these two here. So x squared times x power 3. Then x squared times minus 2, give you minus 2x. You write it under this x squared. So they must be under each other. The x cubed must be under the x cubed. The x squared must be under the x squared. So once you get here, you subtract. You subtract x cubed minus x cubed, 0, right? So is 0 x squared minus 2x squared. That will be positive 2x squared because negative times negative is positive, right? So here, guess what? Positive 2x squared, right? So then you pull down your next term. You put the next term down, which is negative 16x. You pull it down, right? Then we have this. Then you start all over again. 2x squared divided by x. 2x squared divide x will give you positive 2x. So now what do you do with the positive 2x? You use the positive 2x to multiply the two terms. Positive 2x times x, positive 2x squared. Positive 2x times minus 2 will give you negative 4x. So negative, the x squared under the x squared, the x under the x. So when you get here, what do you do? You subtract as well. So then you do your line under. You understand? To see the subtraction, see how we subtract it. So 2x squared minus 2x squared give you 0. So nothing is remaining there. So minus 16x minus 4x. So that'll be negative 16x minus 4x. That'll give you negative 16x positive 4x. And that'll be negative 12x. Right? That'll be negative 12x. Right? Then lastly, you pull down the last term here. You pull it down. Then you have negative 12x plus 4. Then you start again. Negative 12x divide x. And now you'll be left with negative 12. So the answer, you put here negative 12. What are you going to do with it? You're going to use it to times both of these terms. Negative 12 times x. Negative 12x, right under the x. Negative 12 times negative 2 will give you positive 24. Then you subtract again. Subtracting minus x minus 12x minus 12x. That'll be minus 12x plus 12x. And that'll give us 0. And then 4 minus 24 will give you negative 20. Right, and it said this is your remainder. So basically, we're saying our dividend, which is your polynomial, is equals to this multiplied by this plus this. So when you try to multiply x minus 2, if you multiply it with x squared plus 2x minus 12, and you subtract 20, if you put them all together, if you multiply these two brackets, and then you subtract 20 from it, then you will get your when you multiply your divisor, multiply by your quotient plus your remainder, then get your dividend or the polynomial. So, and then so basically this is your answer and this is your remainder. All right. So in general terms, so generally we say what? Dividend is always equals to your quotient multiplied by your divisor plus your remainder. So we end it here this afternoon. So tomorrow we'll carry on with the next topic. We carry on with the next topic, and then the next topic will be the angle of inclinations and equation of straight lines. All right. So thank you very much for attending and enjoy the rest of your day. All right, guys.